Hi students, in this section, let's discuss the type of questions that we call sigma n questions. Now, say you want to find the sum of the numbers from 1 up to n. So that would be 1 plus 2 plus 3 plus 4 up to n, right? This is what we call as sigma n, alright? It's the sum of the numbers from 1 to n. And if you want to find this is equal to n into n plus 1 divided by 2, alright? Let's try to analyze the sigma n series. Alright, now if n is equal to 1, you just have one number, right? So the sum of the numbers up to 1 will be 1 itself. So when n is equal to 1, you get the sum as 1. Now when n is equal to 2, the sum is 1 plus 2, that's equal to 3. Alright, now when n is equal to 3, it's 1 plus 2 plus 3, that's equal to 6. Similarly, if n is equal to 4, it's 1 plus 2 plus 3 plus 4, that's equal to 10, right? Now you can see over here, say for example this one, over here we have seen n is equal to 4. As per this formula, it's 4 into 4 plus 1, which is 5 divided by 2, and you can see that's equal to 2 into 5, which is 10, which is what we have got over here. Alright, the sigma n series is the set of numbers that's 1, 3, 6, 10, etc. That's these numbers. 1, you have 3 over here, you have 6 over here, and you have 10 over here. Whenever you see numbers like 1, 3, 6, 10, etc. in a question, try to relate it to the sigma n series and try to think whether you could use this in solving the problem. Let's do these two questions. So we have two questions over here. The first one reads, a boy was adding the page numbers of a book starting from 1. He missed a page number and he got the sum as 50, right? Now, we need to find which page number did he miss. The second question says, a boy was adding the page numbers of a book starting from 1. He counted a page number 2 times and got the sum as 68. Which page number did he count 2 times? Alright, pause the video, give it a try, and then we'll do it together. Alright, I hope you have given it a try. Let's do it together. Let's start with the first question. Over here, it's mentioned that he has missed adding a page number, right? And if you see, adding the page numbers is of the form 1 plus 2 plus 3 plus 4, etc., right? Whenever you see this, immediately you should relate this to a sigma n question. And we know what's the formula for sigma n. It's n into n plus 1 by 2. Alright, now because he has missed a number, the sum he should have got if he did not miss that number should be greater than what he got, right? So currently he has got 50, so the actual value should have been greater than 50. Therefore, we need to find the nearest sigma n number on the higher side of 50. Alright, now by trial and error, let's just try sigma n when n is equal to 10. So that would be 10 into 11 by 2, which is equal to 55, right? Now, if we see the lower one, when n is equal to 9, that's 9 into 10 by 2, which is equal to 9 into 5 or 45, right? And we want to find a sigma n on the higher side of 50. So 45 is lower than 50. So sigma n when n is equal to 9 is not enough. And when we take sigma n when n is equal to 10, we get 55, which is higher than 50. So this will do. Alright. Now, to find the number that he missed, we just need to subtract 55 minus 50. So when we do that, we get the answer as 5. So 5 is the number of the page that he missed to add, right? So if he had added all the page numbers correctly, he would have got the answer as 55. Because he missed 5, he got the sum as 50. Alright, let's keep this aside. Let's try to do the next question. In this case, it's mentioned that he has double counted some page, right? So, and he got the answer as 68. Therefore, the actual sum should be lower than 68, right? It will be lower than 68 because he got 68 by counting some page number 2 times. Alright, now, therefore, we need to find the nearest sigma n number on the lower side of 68. So let's try to take some numbers and find the sigma of numbers up to those numbers. We know sigma n when n is equal to 10 is equal to 55. So we have seen that over here. Now we need to check whether this is the nearest sigma n number to 68. So let's try sigma n when n is equal to 11. So that would be 11 into 12 by 2, which is equal to 66, right? That's 11 into 6, which is 66. So 66 is still more close to 68, and we can see that it's very close to 68. So this will be the nearest sigma n number on the lower side of 68. All right. Now to find the answer, that is what page the boy has counted 2 times, we just need to do 68 minus 66, which is equal to 2. Therefore 2 is the page number that the boy counted 2 times, right? Let's quickly revise. The boy counted a page 2 times, therefore the value that he got is greater, so the actual value he should have got is on the lower side. So we are trying to find the actual value that he should have got. So over here we see that the actual value which the boy should have got is 66. He got 68 because he counted 2 times. All right. And over here, in the case where he missed a page number, we found the sigma n number on the higher side of 50. We got that as 55. So he should have got 55 as the answer, but he got the answer as 50 because he missed counting page number 5. Let's do this question. You are given a series A, B, B, C, 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 D, 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 etc. And we are asked to find in this series, find the 310th term and 178th term. Alright, pause the video, give it a try, and then we'll do it together. Alright, I hope you have given it a try. Let's do it together now. The given series is A, B, B, C, 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 D, 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 etc. Right? Now, when you see a series like this, there is an interesting thing that you can observe. Let me write the position values. This is 1, this is 3, right? Over here you have 6, over here you have 10. So when you see the numbers 1, 3, 6, 10, immediately it should strike you that this is nothing but the sigma n series, right? Sigma n when n is equal to 1 is 1, sigma n when n is equal to 2 is 3, sigma n when n is equal to 3 is 6, sigma n when n is equal to 4 is 10, and it goes on like that, right? Now therefore we need to find a sigma n number close to these terms that we need to find out. So for example, let's simply try sigma n when n is equal to 20. So that, as per the formula, n into n plus 1 by 2, right? That's the formula for sigma n. That's over here, it will be 20 into 21 by 2, and that is 10 into 21, which is 210. So we start with this one over here, 310. It's still far away. So let's try sigma n when n is equal to 30. Alright, so that is 465. So that's greater than 310. So let's try something in between 20 and 30. Say let's try sigma n when n is equal to 25. Alright. Over here we can see sigma n when n is equal to 25. We are getting 325. That's close to 310. Let's try sigma n when n is equal to 24. That's 300. So what does this actually mean? It means that the 300th term has the 24th alphabet, right? Why is that so? Over here you can see that when you take sigma n when n is equal to 2, you got the answer as 3, right? We know that. That's just 1 plus 2, which is equal to 3. So that means the third position, right? Third position, let me write that over here. The third position has the second alphabet, which is B. Similarly, over here you can see that the 300th position has the 24th alphabet, right? That's what we can learn from this part over here. And you can also see that the next sigma n number is 325. That means the 325th position has the 25th alphabet. Now the number over here 310 is in between 300 and 325. So all the numbers from 301 till 325 will have the 25th alphabet, right? Over here you can see that the numbers from 2 till 3 have the second alphabet, or over here you can see the numbers from 4, the positions from 4 till 6 have the third alphabet. In a similar manner, let me make some space over here. In a similar manner, you can see that over here the numbers, the positions from 301 till 325 has the 25th alphabet, right? And our question over here, we have 310. We can see 310 is between 301 and 325. Therefore, over here you will have the alphabet Y, and Y is the 25th alphabet. Alright, similarly, let's try this part. We need to find the 178th term, 178th term. Let me make some space over here. Alright. Now, if we take sigma 18, you will see that that's equal to 18 into 19 by 2, which is equal to 171. Alright, that's close. Now let's try sigma 19. You get sigma 19 as 19 into 20 by 2, which is equal to 190. Now therefore we can see that the 178th term will have the 19th alphabet, right? The terms from the positions from 172 till 190. These positions will have the 19th alphabet, right? And what is the 19th alphabet? It's S, right? S is the 19th alphabet. So over here your answer is S. Hi students, in this section, let's learn some more interesting series which are similar to the sigma n type of questions. So let's club them under the same heading. Now we already know sigma n is equal to n into n plus 1 by 2, right? Now sigma n is 1 plus 2 plus 3 up to n. Now say you have a question where you need to find 1 square plus 2 square plus 3 square up to n square. This can be found out using the formula n into n plus 1 into 2n plus 1 by 6. Alright. Now say for example you want to find sigma n square. Let's call that this as sigma n square, right? This is sigma n square. Let's say we want to find this when n is equal to 3. So that would be as per this 1 square plus 2 square plus 3 square. 3 square is 9, 2 square is 4. 9 plus 4 is 13 plus 1 is 14, right? That's 14. Let's try to apply this formula to get the same 14. So n we know is 3, n plus 1 is 4, and 2n plus 1 is 6 plus 1, which is 7. And we have to divide this with 6. So over here it goes, we have 2 over here, and we get the answer as 2 into 7, which is the same as 14, which we have got over here. Alright, now let me make some space. Let's keep in note this formula over here. It's useful in many types of questions. Now say you want to find this type of a series. You have 1 over here, 1 plus 2 over here, 1 plus 2 plus 3 over here, 1 plus 2 plus 3 plus 4 over here, right? So this is your first term, this is your second term, this is your third term, this is your fourth term, and it goes on like that, and you need to find the sum of these numbers. Now this type of a question, whenever you encounter it, this is a sigma of sigma n type question, right? Because what is this? This is nothing but 1 plus 2 is 3, 1 plus 2 plus 3 is 6, 1 plus 2 plus 3 plus 4 is 10, and we know that 1, 3, 6, 10, etc. is part of the sigma n series. Now because we need to find the sum of these numbers, it's a sigma of sigma n type question. Now we know that sigma n is nothing but n into n plus 1 by 2. So let me replace that over here. So this is equal to sigma of n into n plus 1 by 2. Let me open the bracket and take the 1 by 2 out, right? So this can be rewritten as 1 by 2 of sigma n square plus sigma n, right? Because over here n into n gives you n square and n into 1 gives you n, and that's divided by 2. So this 1 by 2 I am taking out, and in the bracket I am left with sigma n square, taking the sigma in plus sigma n. Now let me make some space over here. say we want to find the sum of the series up to 3. So say for example this much. So over here we can see it's 1 plus 3 plus 6, which is equal to 10, right? Now let's try to find the same 10 using the formula over here. So we take n is equal to 3, right? Now this over here becomes 1 by 2 into sigma n square when n is equal to 3 plus sigma n when n is equal to 3. Alright, so that's equal to 1 by 2 into 14 plus 6, which is equal to 1 by 2 into 20, which is equal to 10. That's the same 10 we've got over here, right? Over here, when n, what is sigma n square when n is equal to 3? It's over here you have 3 over n plus 1 is 4 and 2n plus 1 is 7, and you divide that with 6, right? So we have seen you get 14 over here. That's your 14 over here. Similarly, what sigma n? It's n into n plus 1 by 2, and when n is equal to 3, right? Sigma n when n is equal to 3 is 3 into 4 by 2. That gives you 6. That's your 6 over here. Therefore over here you get your answer as 10, which is the same value if you take the first 3 terms of 6 and over here and you add them up. That's 1 plus 3 plus 6. Alright, let me make some space over here. So we have seen in some questions this type of a pattern will be observed, and if you are aware of this simplification you can apply it to solve those type of questions. Now let's also learn about numbers of the form, say if you want to find 1 cube plus 2 cube etc up to n cube, right? So this is the sigma n cube series, and this can be simplified as n into n plus 1 by 2 the whole square. So it's this in the inside the bracket is the same formula for sigma n, and if you square that, that's equal to this sum over here. Now for example, let's take the first two terms. 1 cube plus 2 cube is 1 plus 8, which is equal to 9. Now over here n is equal to 2. Let's apply that over here. That would be 2 into 3 by 2 the whole square, right? Now this 2 and this 2 gets cancelled, and you're left with 3 square, which is equal to 9, which is the same value that you get over here. So let's quickly revise. We know the formula for sigma n, that's n into n plus 1 by 2. This formula for sigma n square is n into n plus 1 into 2n plus 1 by 6. The formula for sigma n cube, right? That's n into n plus 1 by 2 the whole square. And if you have the case where you have to find sigma of sigma n, that's sigma of n into n plus 1 by 2, which is equal to 1 by 2 into sigma n square plus sigma n, right? You don't need to by heart this. You can just derive it quickly if you want to apply it. And after that you just need to apply the formula for sigma n square and sigma n over here depending on the value of n that you are dealing with in the question. Let's do this question. Find the total number of squares in a 7 by 7 square board. Alright, pause the video, give it a try, and then we'll do it together. Alright, I hope you have given it a try. Let's do it together. Let's try to analyze a 1 by 1 square board first, and then we'll try a 2 by 2 square board. So this can be called a 1 by 1 or a 1 into 1 square board. Alright, now and then we'll derive the pattern, and then we'll go to a 7 into 7 square board. Alright, now over here in this type of a scenario you can see that you can only form one square, right? That's this square over here, right? Now let's take a 2 by 2 square board. That would look like this, right? Okay, over here you can see you have this big square, so that's this one over here, and you can see you have small squares over here of this size, right? That's 1, that's 2, that's 3, that's 4. That's why you have 4 over here. So the total number of squares you can form in this type of a square board is 1 plus 4, which is equal to 5. Alright, now let's take a 3 by 3 square board. That would look like this, right? How many squares do you think you can form over here? You have one big square over here, and you have 9 small ones over here, right? So that's pretty straightforward, similar to this case over here. Plus you have 4 more squares, right? So the total of 1 plus 4 plus 9 squares can be formed over here. So this we have seen is the big square over here, right? The 9 squares over here are these small ones. This is 1, this is 2, this is 3, etc., right? So you have 9 over here, And these four, you can visualize them like this. That's one over here. This is the second one over here. The third one is over here. And this is the fourth one. So you have four squares like this, which you can form. So they are of this size, right? There are four squares of this size. Now, so that's the total of 14 squares that you can form in this case. All right. Now, let's keep that aside. Let's try to analyze this pattern. You can see that over here, this is just one square. This is 1 square plus 2 square. And this is 1 square plus 2 square plus 3 square, right? So, expanding on this pattern that we have seen over here, in the case of a 7 by 7 square board, you can form 1 square plus 2 square plus 3 square up to 7 squares, right? And this is nothing but sigma n square series, where n is equal to 7, right? And we know if you want to find sigma n square, that's equal to n into n plus 1 into 2n plus 1 by 6. And in this case, because n is equal to 7, this is equal to 7 into 8 into 15 by 6, which is equal to 140, right? This is equal to 140. Over here, you can cancel 2 out and you can cancel 3 out like this. So 7 into 20, which is equal to 140. That's your answer to this question. Let's do this question. Find the total number of rectangles in a 7 by 7 square board. Alright, pause the video, give it a try, and then we'll do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now, let's take an n by n square board. Alright, you can see that in an n by n square board, there are n plus 1 horizontal lines, right? And there are n plus 1 vertical lines, right? Is that true? Let's try it out. Say I have a 2 by 2 square board. So that would look like this, right? Now I have 1, 2, 3. That's 3 horizontal lines, and 1, 2, 3. That's 3 vertical lines. So if it's an n by n square board, there will be n plus 1 horizontal lines and n plus 1 vertical lines. And we have seen it over here. It's valid in the case of a 2 by 2 square board. You can also take a 3 by 3 square board and try it out on your own. Now, we need to find how many rectangles can be formed, right? Over here, for example, you can form a rectangle like this. This is a rectangle, or you can form a rectangle like this. Even if you form a square is also a special type of rectangle, right? So that's also a rectangle. So you can see that to form a rectangle, you just need to select any 2 horizontal lines and any 3 vertical lines. Now, this is an application of permutation and combination, right? Now, you can see more on this in sections on permutation and combination. If you want to select 2 out of n plus 1 items, that's equal to n plus 1 C2. So selecting 2 horizontal lines from n plus 1 horizontal lines is nothing but n plus 1 C2. Similarly, selecting 2 vertical lines from n plus 1 vertical lines is nothing but n plus 1 C2. Therefore, the answer to this question is n plus 1 C2 into n plus 1 C2. N plus 1 C2 can be simplified as n into n plus 1 by 2. So this is equal to n into n plus 1 by 2 the whole square. And you can remember that sigma n the whole square is nothing but sigma n cube. So this is nothing but a sigma n cube question, right? Let's keep that aside. And remember this part, if you want to know how this simplifies like this, check any books permutation and combination section, or check our video on permutation and combination. Alright, now let's move on. Now we have established that in this case we need to find sigma n cube, and we know over here we are given a 7 by 7 square board. So that would be equal to 7 into 8 by 2 the whole square, which is equal to 7 into 4, which is 28. So you just need to find 28 square to get the answer to this question. We have learned a method to quickly find the square of numbers, right? So let's find what is 28 square. It will have 3 positions like this. 8 square is 64. So you write 4 over here. Maintain 6 in your mind. It's a carry forwarded. 2 into 8 is 16, into 2 is 32. 32 plus 6 gives you 38. So you write the 8 over here and 3 is carry forwarded. 2 square is 4. So 4 plus 3 is 7. Therefore 28 square is 784 and that is your answer. So you can form 784 rectangles from a 7 by 7 square board.